All right, let's give an overview, an introduction to elimination reactions. When we're doing an elimination reaction, what we're going to be doing is that we're going to be forming double bonds. So anytime you think elimination, we're forming a double bond or a divi. And we don't form it nilly-willy. If you start with an alkyl halide, I need you to mark the alpha. And attached to the alpha, you're going to find the beta carbon. And it's important because the double bond that we're going to be forming, it's going to be between the alpha and the beta carbon. Now there are two ways that I can do this elimination. There's a good way and there's a bad way. The bad way first. The bad way would be to use a weak base. Again, we don't have a long list of weak bases, but we do have water or alcohol. So you can use water or an alcohol as your weak base, and you can actually make the double bond in there. That's what we call the E1 elimination. And since it's E1, the 1 means that it's a carbocation mechanism. So if you have a tertiary or a secondary alkyl halide, then they can actually undergo the E1. Notice this one is a primary alkyl halide, so if it reacts with a weak base, it's not going to react at all because it cannot do the E1. The second reaction that we have are going to be with strong bases. Ignore the phone that's ringing. So if we have strong bases, we're going to do a much better mechanism. It's going to be the E2 mechanism, and this is the good reaction, the good, oh my goodness, is it good? It's a very good reaction because this reaction is driven by the strong base. And why does that matter? Well, if it's driven by the strong base, what matters is how many hydrogens you have on the beta carbon, because that's where we're going to actually get the hydrogen from. And this one, it doesn't matter what alkyl halide you have. All alkyl halides can undergo the E2 reaction with a strong base, but notice tertiary alkyl halides can undergo the E2 faster than secondaries, and the secondaries are going to be faster than primaries. And you're asking yourself, why? Why is that? Well, how many beta carbons are in a tertiary alkyl halide? You have 3, that's why it's tertiary. So the tertiary alkyl halide would have more hydrogens on the beta carbons. So more hydrogens that the strong base can actually go to. Primary alkyl halides, they tend to have just 2 beta hydrogens, or maybe 1. So they have less beta hydrogens than the tertiaries. And that's why the tertiaries are going to react faster than the primaries. So the E1, that's a bad reaction. The E2 is a much better reaction. So this one is the one that we want to use when we're making double bonds.